Swayam Prabha. Digital India. Educated India.
Welcome back to the 11th lecture in this project management, which is a 20-hour program under the NPTEL MOOC ambit. So, as we were discussing the AHP problem, where I just mentioned in the last slide before I closed the last lecture, you were trying to select a car which is one of from this list Civic, I-20, Escort and Alto, which is the last level which you see here. And if you remember, I did mention about style, cost and fuel economy. So, they can be broken down into tertiary and more such levels. So, this is the primary hierarchy. I am not going to go into much so called complication, but just simply consider the problem such that it will give a good flavor of how AHP can be used. Now, according to Sati, the intensity of the importance when you are trying to compare two different criteria, they are done on a 1-to-1 scale, like 1-to-1 basis. I should not use the word scale. Basis means, say for example, if there are 3 decisions, you will try to compare decision 1 with decision 2, decision 2 with decision 3 and again decision 1 with decision 3. So, you will basically have binary comparison being made between the criteria, whether at first level, second level, third level. Level, by the word level I mean the hierarchy, the primary, the tertiary, the secondary. So, when the level of importance between two criteria, or say for example, when you come to the alternatives also considering the overall choice, if it is of equal importance, you give a point of 1 between them. Two factors contribute equally to the objective, and which is to buying the car in this case, hence you give a weightage of 1. Then if you give one of this criteria 0.3, point means not the decimal point, the point of level 3, which means that in a sense if you are forced to take the other criteria, then the overall benefit which you will get by taking that criteria into your consideration would give you a score of 1/3. That means, higher the score for taking 1, it would mean on the reverse scale it will be lower the score for the other. So, similarly, if I go 3 means somewhat more importance, experience and judgment slightly favor one over the other. Similarly, as I continue, it is 5, 7, 9, which technically means much more important, very much more important, absolutely essential, and the explanations are experience and judgment strongly favor 1, which is for point of 5. For 7 it is experience and judgments very strongly favor, while for 9 it is the evidence of favoring one over the other of the highest possible validity or level. Now, if obviously you may think that why the even numbers were not taken. So, even numbers as prescribed by Sati, those 2, 4, 6, 8 are intermediate values when compromise is needed between, say for example, criteria 1 and criteria 2 or criteria 3 and criteria 4 and so on. So, if they are of equal importance or you are not able to give a decision, you will give the even points, but generally we will consider the odd points, that means 5, 1/5, 3, 1/3, 7, 1/7, 9 and 1/9, based on which you will make a choice between two criteria at whatever level it is. Level means the hierarchy. So, now if I go to the primary hierarchy, if you remember there was style, cost, fuel efficiency. Now, consider arbitrarily person 1 is trying to make a decision without thinking the alternatives, only concentrating on the criteria. So, he or she when is trying to analyze style to style, cost to cost, fuel economy to economy, which is the principal diagram, over it will be 1, that means you are indifferent. But when I consider cost to style, then you will see the level of cost is much more important to you, who is the person who is making the decision, hence you give a score of 2. Now, if you were forced to take style into consideration with respect to cost, then the overall score would be half. That means, you are now being the overall utility or the overall the benefit which you are trying to get by taking the decision related to style only for that criteria with respect to cost is giving you a benefit of half only. Similarly, when I go into style and fuel economy, the overall scores are 3 and 1/3. If I go to cost, then it is 4 and 1/4 between cost and fuel economy. So, these points which are given for these examples are arbitrarily, but they definitely do make sense if somebody is asked on a qualitative scale that what are the different levels of importance one would like to place on different criteria at different levels. So, if I am considering primary hierarchy, I will compare them. I means the only one person who is there will compare all the criteria, and then go into the secondary level, tertiary level, I will have different matrices with these type of scores. Similarly, when person 2 comes, he or she will again analyze the same set of criterias, primary, secondary, tertiary based on the scores, but the scores would obviously be different. And then what would be done is that if there are 3 different persons, each of them give their scores, the overall analysis is done, and then the decision for all these 3 different persons are combined to give the best possible decision for the overall project which you are considering. So, in analytic hierarchy process, we use the concept of the eigenvalues and the eigenvectors. So, consider that very simply that matrix A which is there, which has to do something with the scores. I will come to that within 1 minute in the same slide. So, we want to find out the maximum value of the eigenvalues. So, where A is the comparison matrix of size n cross n depending on how many such criteria which you have at each level. So, it would be at each level different criteria, set of criteria are there. I will definitely have different type of sizes of matrix A. For n criteria, so if you see that there is n criteria depending on which level you are. So, in this level for the car buying one, we have 3 cross 3. So, it is also called the priority matrix. So, in the case if we in economy, if we had 2 such tertiary or the secondary criteria, sub criteria for economy. So, it will be a 2 cross 2 matrix. If say for example, style had 3 in the secondary level, it will be a 3 cross 3 matrix corresponding to the sub criteria of style. So, X is the eigen vector of size n cross 1, also called the priority vector, and lambda max is the eigenvalues. To find out the ranking of the criteria, namely the eigenvalues we have to use. So, I am not going to the theoretical solution concept, I will just solve it using the problem as we are going ahead. So, normalize the columns entries by dividing each entry by the sum of the column. So, if you see the scores which we had given initially, person 1, the principal diagonal was all 1 1 1, and the scores for say for example, the second row and the first column, that top point 2 was given, the other opposite value to the principal diagonal was half. So, hence it is 0.5. So, if you consider the first row and the third column, the value was 3, the opposite value which is 1/3, which is 0.33. So, similarly you have matrix A as given. Now, you normalize the score. This normalization of the score is done in such a way such that if you see the column sums. So, the column sums are given for first column 3.33, 1.75, 0.8. What you do is that divide each individual value by the column sums and you normalize them. So, hence the sum along the columns are 1. And then what you do is that you find out the row averages. Now, having said that, it is also possible to do the row sums, they are 1, and do the normalizations accordingly, which means that rather than finding out the sums along the column, you can do it along the row, and normalize it accordingly, and then you get the values of the priority vectors, but we will stick to whatever we are doing now. So, once you do it, the criteria weights are given as 32%, 56% and 12%. So, if you add them, it comes up to 1, which means that when person 1 is trying to analyze the first level of criteria, which is style, cost and fuel economy, for him or her, cost is the most important factor with a weightage of 56%. Now, if person 2 has done it, obviously the matrix A would have different values in the cells. In that case, the overall criteria weights for style, cost and fuel economy would be different for person 2. Now, similarly, it will be different for person 3, person 4 and different type of people who are there making the decision. Now, if consider person 1 is doing the tertiary or the secondary ranking of the criteria or the sub criteria, then obviously he or she would get different such criteria weights for the second level. Similarly, for person 2, person 3, person 4. Now, selecting a car in the diagram shown in the green one, which is this one. So, there the person gets the weights as 32, 56 and 12. The next stage is to calculate the consistency ratio value. So, consistency basically means how consistent the decision making is. So, obviously, you are trying to give, you means as one of the person who is trying to rank the criteria in order to make a choice among the alternatives. So, in that case I want to find out, or the decision maker wants to find out in a sense, that how consistent are the rankings based on which the final decision can be taken. So, this CR is to measure how consistent the judgment has been relative to the large samples of purely random judgments, because they are just random. If I ask one person to compare between fuel efficiency and economy, it may change from day 1 to day 2. So, I am trying to find out what is the best judgment. AHP evaluations are based on the assumptions that the decision maker is rational, which may not be true. So, if A is preferred to B and B is preferred to C, then A is always preferred to C, which may not be true in many of the practical sense. So, if CR is greater than, say for example 10 percentage or 0.1, the judgments are untrustworthy because they are too close to comfort and bring into the realm that randomness really does play a part. So, the next stage is to calculate lambda max so as to lead to the consistency index and the consistency ratios. Consider, as I had already mentioned, that you are basically trying to consider A lambda is equal to Ax is equal to lambda max into x. So, this A was that matrix of the weights, x is the eigen matrix and eigen values, where x is the eigen vector as I mentioned. So, and these A which I have found out, I want to find out x. Now, x I have already found out using the normalization. So, what I have is basically value of lambda max. So, once I multiply A into x, I would basically have the value as lambda max. So, that lambda max on an average would give me the consistency ratios and the CI index. So, I do it very simply using that lambda max is the average of these values. So, average means 0.98, which is by multiplying this into this gives you, that means 1 into 0.32 plus 0.5 into 0.56 plus 3 into 0.12 would give you a value of 0.98, and I find it out. Though these values are 0.98, 1.68 and 0.36. So, I try to find out the lambda max value such that is the ratios of 0.98 to 0.32. 32 is the 32%, 56% and 12 what I have already found out. There the value comes out to be 3.04. Now, here the sample size is, there are 3. Sample size means how many such criteria are there. Based on that, I find out the value of the consistency ratio index as 0.02. Now, consistency ratio is basically the ratio of CI index by RI. So, RI values are the random index which are given in the literature. So, N means the number of observations I have, 1, 2, 3, 4 depending on or number of such criteria I have in any level. I am not combining different levels like primary, secondary, tertiary are separate. So, once I find out for 3 it is 0.02 as I found out, and as per the calculations given in the table it is 0.52, then I will find out that the value of CR comes out to be 0.04, which indicates sufficient consistency in the decision, because the cutoff value as you mentioned was 10% or 0.1. So, it can be done. So, if you are satisfied with first level of the decision making for the criteria by person 1, you will go into similarly the decision making for person 2 in the same set of criteria for the same level, and continue doing it for the third person, fourth person, fifth person for the first hierarchy. Then you will shift to the second hierarchy, do it for the first person, second person, third person, and continue doing that such that there is no inconsistency in the decision making process for each and every individual, considering conglomeration of criteria at different levels. So, now what I do is that I now compare the alternatives. So, if you consider the alternatives based on the criteria, this is where the things are generally very interesting. Now, what I have done is that for each individual in the first sense, they had compared the criteria amongst themselves. Now, what I am going to do is that I am going to compare the alternatives based on each and every criteria at one go. So, point 1 will be comparing the alternatives for criteria 1, point 2 would be comparing the alternatives with respect to criteria 2, and so on and so forth for all the different type of criteria I have. So, it will be for level 1, level 2, level 3, but as we have only one primary level, we will only do it accordingly. So, with respect to style, if I compare the alternatives, you see this principal diagram again is 1. Now, if I compare civic to I-20, it means generally the overall point which I am trying to give between civic and I-20 are in the ratio of 4:1/4. So, this 4 and these values I have just utilized the values of even and odd in order to make a comparison that how the values of even and odd when you are trying to utilize, consider the decision maker is not aware, it would not affect your result much, because it will give you in a very nice manner that how you can conglomerate all the decision making processes for different individuals. So, first set of values which is there, where I hover my pen, is for the style for all the 4 alternatives, next one is cost for all the alternatives, and these are the priority vectors which I have. So, technically it means that if on a qualitative sense, if I am only considering style, I would give my maximum point to alto, which is 56%. If I go to the cost factor, it would mean that I will give my maximum amount of points would be of 38% for the cost factor only for all the 4 alternatives. So, obviously, they are different to each other. This priority matrix and this priority matrix consider that only in the first case only style is the factor. In the second case, cost is the factor. So, you are trying to analyze each individual criteria for each alternatives on a case by case basis. If I consider the fuel economy, so here the rankings are given. So, these are the miles per gallon which I have 34, 27, 24, 28 are the miles. 1 gallon would be utilized to drive these cars, Civic, I-20, Alto and Escort and Alto, and the priority values again vector is given. Remember, double check the concept which you are trying to utilize, as I mentioned, whether you are trying to use the column normalization or the row normalization, and at the end of the day the sum should be 1. So, note, since fuel economy is a quantitative measure, fuel consumption ratios can be used to determine the relative ranking of the alternatives. So, what we have done is based on that only. Now, once the overall the points are given for each and every alternative, for each and every criteria, what I do is that I have in this level, again going back to the same set of diagram which I had. Your main aim is to select the car, and the three primary criteria were style, cost and fuel economy. If you remember, they were of the level of 32%, 56% and 12%. Now, when I try to compare all the 4 cars for style, all the 4 cars for cost, all the 4 cars for fuel economy, there the second level of point sharing are accordingly. So, what we have just found out. Now, as I proceed in the next slide, it will be it's shown that what I want to find out is the overall score based on the fact that you have been able to compare the criteria among themselves and you have been able to compare the alternatives based on each and every criteria, single criteria at each and every stage. So, once I do that, here for the first time I would have basically the matrix where in the leftmost line you have the different type of alternatives and the topmost part you have the different type of criteria based on which you are trying to take a decision. So, the priority matrix is now a conglomeration of all the criteria for each and every individual combined together. So, the criteria weights are given which you have already found out when you compare them, and when you multiply in them you basically have the overall score based on the fact then the alternatives have been compared for each and every criteria. So, analytical hierarchy process including cost as a decision criteria. So, now if I consider adding a cost as a new criteria becomes very difficult, because if you add the cost factor it would mean that you have to add a column, do your calculation and repeat it for all the factors, because now cost is a criteria. So, you have to basically bring that in the picture and include that cost as a criteria and compare the alternatives based on the new set of criteria. Consider there were already 4 criteria, cost came into the picture. So, and there were 10 different alternatives. So, each alternative would now basically be compared on the overall set of criteria where now cost is also a part and parcel of one of the criteria. So, you will again do the calculations accordingly. However, the whole evaluation should be repeated since the addition of a new criteria might affect the relative importance. Instead, one may think of normalizing the cost directly and calculate it accordingly. So, once you have the cost factor, cost means not the fuel factor, the cost of each and every car, you normalize it, you find out the benefit with respect to the cars which you have, and then you find out the cost benefit ratios which is given on the last column. So, if you basically now try to find out the overall cost ratio based on which you will take the decision, then obviously it will mean that Ascot is the first one, second one is I-20, third one is Alto and the fourth one is Civic. So, what you are trying to do is that you are trying to add up the weights for each and every criteria and each and every alternatives and add them up in such a way that the overall value for the alternative considering all the criteria are taken into consideration is the maximum. So, analytical hierarchy process has many pros and cons. So, I will discuss that, and I will also would try to tell to my students that even though the problem was very simple, there would be different type of books in where people can refer the concept of AHP and understand that how AHP is used, and obviously there would be simple assignment also which will help them to clear the doubts, and we are there to help the students in order to clear the doubt and proceed with the concept of AHP and other problems which we will consider. So, the pros are it allows multi-criteria decision making, that means you are trying to basically take different type of criteria in order to make a decision. It is applicable when it is difficult to formulate criteria evaluation, that means where qualitative field has also to be brought into the picture. That means it allows qualitative evaluation as well as quantitative evaluation, and also do the fact that rationality may not be there in many of the decision making process, because if you consider the concept of consistency ratios and the index, it will give you a good picture of whether the decision based on the criteria or all the alternatives are rational or not. It is applicable for group decision making environments and gives you a collective decision that how different sets of people do make a decision. While on the other hand there are hidden assumptions like consistency, repeating evaluations is cumbersome, because if you remember in the problem where we just considered if cost is brought in the factor, it may as a new item, it may so happen that you would be tempted to ignore the other alternatives or the criteria values on the alternatives and go ahead in trying to do the calculation. But obviously, it would mean that you have to do all the calculation based on the fact one or two or three different criteria, whether in level 1 or level 2 or level 3. That means, primary, secondary and tertiary are into the picture, such that it will give you a good feel that how in an overall sense you are able to bring the adjustment for all the criteria in order to make the best possible decision. It is difficult to use when the number of criteria or alternatives is very high. Say for example, they are more than 7, then trying to do the calculations for a 7 cross 7 matrix repeatedly, because there would be sub criteria, tertiary criteria, it may become difficult. It is difficult to add a new criteria, because as I said that it would basically take some time to do the adjustment, but generally there are different type of packages which helps in trying to make the decision much more easier. That means, doing the calculation much easier. So, it is difficult to take out an existing criteria. So, now adding an alternative or adding a criteria becomes easy, but if you want to take out then trying to compare and trying to do the comparison at one go may become difficult. The reason is very simple. I will try to give you a qualitative feel. Whenever you are comparing the alternatives and the criteria, remember they are done on a one-to-one basis. So, if there are 4 such alternatives or 3 different type of criteria, you will try to compare the first to the second, second to the third, first to the third, and continue considering the criteria. If in the secondary level, if there are 5 different criteria, it will be first to the second, second to the first to the third, first to the fourth, first to the fifth. Similarly, you will do the second to the third, second to the fourth, second to the fifth, and continue doing that. Whenever we are trying to make a decision between 2 distinct criteria or even between 2 distinct alternatives based on any one criteria, the fact always remains that you are trying to ignore the other sets of criteria which are available. In a sense that if you are trying to compare person A and person B, decision A and decision B, project A and project B, you would tend to ignore the other existing projects, such that the decision making which you are trying to make between A and B is on a standalone basis. That means, you are not trying to basically consider all the other projects or all the other alternatives which may affect your decision between A and B only. Point 1. Point number 2 is that, so this is a big point to be noted for AHP, even though on a very simplistic sense the actual calculation which you do for AHP does give you good results. Another important factor is that when you are trying to compare 2 different alternatives or 2 different criteria, it may so happen there is a gray region such that you are indifferent between criteria 1 and criteria 2. Now, if you remember, when we are basically mentioning the scores 1, 1 if they are of the same level, 2, half, 3, 1/3 and points accordingly, you were always able to take a decision that whether you like or dislike one, but it may so happen that in many of the cases that trying to take a decision whether you are forced to take A or you are forced to take B does not give you the maximum benefit which you want actually. So, in those cases there would be some indifferent region or neutral region where you would not be tempted to take either decision A or alternative A, such that trying to analyze those type of problems using AHP may not give you the best result. That means, now your decision making is basically divided into three such final outputs. One, I definitely like A, one I definitely like B, and another is that I am indifferent. Having said that, also remember that if I am being forced to take decision A with respect to B, my liking to take A or my liking to not take B would basically be of a different consequence if I am being forced to take decision B. So, if I am for A, my liking for A would be much higher than if I am able to take a decision B where I do not like B. So, all these nuances would definitely be not possible in the simple AHP concept, but I am sure the students would be able to appreciate AHP once they solve the problem and understand the assignments which is given. With this, I will end this lecture and continue the discussion of the project management for other different type of topics of decision analysis and other related issues. Thank you very much.